Hello everyone. Today we will start the chapter number 6 epoxides. Epoxide have the three-member heterocyclic ring. Epoxide have three-member heterocyclic ring with oxygen atom in the ring. Epoxide have three-member heterocyclic ring with heteroatoms such as the oxygen is present in that ring, which is also called as a oxygen ring, which is also called as a oxygen ring. The most important epoxide is a ethylene oxide. The most important epoxide is ethylene oxide and also known as oxygen. Also known as a oxygen. These compounds are also referred as cyclic ether. These compounds also referred as cyclic ether or alkaline oxides or alkaline oxides. This epoxide have the three member ring. Okay, 1, 2, and 3. Okay, CH2, CH2, and oxygen. This now the oxygen is present in that ring. Okay, this is called as a ethylene oxide or epoxy ethane. Epoxy ethane. Now the another example is CH3, CH, CH2O. Okay, this is a 1, 2, and 3. Okay, 1, 2 epoxy, 1, 2, and 3. Okay, 1, 2 epoxy, 1, 2 epoxy propane. There are the three carbons in a one chain. Okay, 1, 2, 3. Okay, 1, 2. पहिल्या आणि फर्स्ट आणि सेकंड पोझिशन ऑक्सिजन ग्रुप असले इथं रिंग असणार इथं थ्री मेंबर रिंग. ओके, 1, 2 epoxy propane or propylene, propylene oxide. Now, nomenclature of epoxide. They are two systematic way to name epoxide. They are two systematic way to name epoxide. According to the one method, the three-member oxygen-containing ring is called as a oxygen. The three-member oxygen-containing ring is called as a oxygen. Is called as a oxygen. There are two systematic ways to name epoxide. According to the one method, three-member oxygen-containing ring is called as a oxygen with oxygen at a position 1. With oxygen at a position 1. It's 1, 2, 3, 4. Okay. The number is starting from the 1. Okay. From the oxygen. They are the two systematic way to name epoxide. According to the one method, the three-member oxygen-containing ring is called as a oxygen with oxygen at a position 1. Oxygen ची position काय असणार आहे? 1 असणार आहे. That is a 1, the 2 ethyl. Okay. 2 ethyl oxygen. 2 ethyl oxygen. 1, 2. Okay. Second position ला काय असणार आहे? Ethyl group. 1, 2. 2 ethyl oxygen. This is a three-member ring is called as a oxygen. Okay. The three-member ring is called as a oxygen. And second position ला काय असणार आहे? Ethyl group असेल. The 2 ethyl oxygen. So name काय असणार आहे? 2 ethyl oxygen. The another name, another example is the one, the number is starting from the oxygen 1 and 2. Okay. 2, 2. The second position, there are the two methyl groups is attached to carbon atoms. Okay. 1, 2. 2, 2 dimethyl oxygen. 2, 2 dimethyl oxygen. Now, the another example is the epoxide can also be named as an alkane. The epoxide can also be named as a alkane with the prefix epoxy. With the prefix epoxy. The two numbers designate the location of the atoms to which the oxygen is bonded. The two numbers designate the location of the atoms to which the oxygen is bonded. The one example is that here this is a cyclohexane and this oxygen is attached here. Okay, oxygen is attached here. That is a 1, 2, 1, 2 epoxy. Okay, 1, 2 epoxy. 1, 2 epoxy cyclohexane. Okay, 1, 2 epoxy cyclohexane. The name of this compound is a 1, 2 epoxy cyclohexane. 1, 2 epoxy cyclohexane. The another structure, another example is CH3, CH, CH, CH3. Okay, this oxygen is between the second and two, three carbons. Okay, one, two, three, four. Okay, now this is the name of this compound is a 2,3 epoxy. Okay, 2,3 epoxy butane. There are the four carbon atom in one chain. 2,3 epoxy butane. Okay. Now the preparation of epoxide. How to prepare the epoxide? The first method is that the preparation of epoxide from the oxidation of olefins by the oxidation of olefins. The ethylene oxide means epoxide can be prepared by direct air oxidation of ethene. The ethylene oxide can be prepared by direct air oxidation of ethene in the presence of the silver catalyst. In the presence of the silver catalyst. Similarly, the propylene oxide, this propylene oxide can be obtained from the propene. Can be obtained from the propene. Means the ethylene oxide epoxide can be prepared from the alkenes. Okay. Now, very simple example, the ethene. Okay, CH2 double bond CH2, the oxidation of ethene. Okay, air oxidation. Okay, air oxidation is plus half single oxygen. Okay, plus half oxygen O2 in the presence of the silver catalyst, and this oxygen, single oxygen, is attached in between these two CH2. Okay, now this double bond is converted into the single bond here. Okay, here the to prepare the here the three-member ring, that is called as the ethylene oxide CH2 CH2O. Okay, three-member containing the oxygen atom, that is called as the oxyrane. Now the another example is the CH3 CH double bond CH2. That's the propene. Okay, the addition of oxygen in between the double bonds. Okay, the addition of oxygen is between the double bond here in the presence of the silver catalyst. Okay, then to form this the propylene oxide, one, two, three member, there are three carbon atoms. Okay, the propylene oxide can be prepared here. This in the first example, the ethylene oxide can be prepared from the ethene. Okay, and in second example, the propylene oxide can be prepared from the propene. Okay, this oxidation of alkenes has a great importance because the epoxides are used as a starting material for many other organic compounds. The epoxides are used as a starting material for many organic reactions. Now the second method is the preparation of epoxide by the action of peracid on olefins. The preparation of epoxide by the action of peracid on olefins. Olefins means alkenes. Okay, the epoxide can also be prepared by the action of organic peracid. The epoxide can also be prepared by the action of organic peracid on alkenes. Means alkene is a reacts with the peracid. Is a reacts with the peracid. Now, what is the difference between the acid and the peracid? Suppose it's a simple general carboxylic acid, RC double bond O OH. Okay, RC double bond O OH. This is a acid. This is a functional group of acid. Okay, C double bond O OH. Now, in a per acid, one oxygen is extra here. The one oxygen is extra in between the carbonyl group and the hydroxyl group. There are the three oxygen, one, two, and three. Okay, this one oxygen is extra. Okay, is between the carbonyl group and OH group. That is called as a per acid. Okay, that is called as a per acid. This is the electron. They are the lone pair of present on the oxygen atom is present. It's the electron rich. Okay, electron negative elements. So then the electrons can be here the delocalized here the then the here the negative charge is present on the oxygen atom. Okay, per acid here the. Now this alkenes, carbon carbon double bond is that is the alkenes is a reaction with the per acid. Okay, is a reaction with the per acid, then the formation of the epoxide, then the formation of epoxide. Okay, now the epoxide can also be prepared by the action of per acid with alkenes. An oxygen atom, one oxygen atom, okay, from the per acid, one oxygen atom from the per acid is added to the across the carbon-carbon double bond, okay, to give the epoxide. One oxygen atom from the per acid, which is added to the across the carbon-carbon double bond, okay, to give the epoxide. This reaction is called as a epoxidation. This reaction is called as a epoxidation or per oxidation of an alkene. The per acid likes peroxybenzoic acid, peroxybenzoic acid, peroxyformic acid, peroxytrifluoroacetic acid can also be used. Okay, these are the number of examples of the per acid. Means benzoic acid C6H5, C double bond O OH. Okay, OH. Per formic acid H, C double bond O OH. Okay, per formic acid, trifluoroacetic acid can also be used. The reactions is carried out by mixing. The reaction is carried out by mixing an alkene and the per acid in a solvent like the ether or chloroform. When the reaction can be takes place between the alkene and the per acid, this reaction takes place in the medium solvent like the ether or the chloroform, and the mixture is allowed to stand. This mixture is allowed to the stand. Now there are some examples. The first example is a alkene is a reaction per acid. One oxygen is attached the across the carbon-carbon double bond, then to give the epoxide. Okay, and the remaining is right here the per acid RC double bond OH. Now the another example, very simple reaction. The CH2 double bond CH2 ethene. Ethene is a reaction the per oxyacetic acid CH3 C double bond OH. Okay, ethene is a reaction the per oxyacetic acid. This one oxygen is added to the across the carbon-carbon double bond, then to give the ethylene oxide, plus right here the subproduct acetic acid CH3 C double bond OH. Okay. Now the another example, the propene CH3 CH double bond CH2 is a reaction the per oxyformic acid H C double bond OH. Okay, this one oxygen is added to across the carbon-carbon double bond. The addition of oxygen takes place across the carbon-carbon double bond, then to give propylene oxide, then to give the propylene oxide 1, 2, 3. Okay, then to give the propylene oxide plus formic acid means in this method, okay, the addition of per acid with alkenes, then the addition of oxygen from the per acid is added to across the carbon-carbon double bond, then to give the epoxide.